Okay, hi, thank you. My name's Rebecca Silkstone. I'm here from Audiology at Addenbrooke Hospital, and our interest in sticklers is from the side of hearing and balance function. And we're really excited to be starting a research project in the coming month, actually, where we're going to be looking at a specific subset of sticklers that, as Thomas mentioned earlier, was the one that affects type 9 collagen. Okay. So just to talk about hearing in general, hearing loss affects the inner ear, which is a sensory neural hearing loss. And that's sort of this area here, this sort of snail-shaped organ of the inner ear. Or you can have like a conductive hearing loss, which means that the area between the eardrum and the inner ear is affected, that middle ear space. And patients with Stickler Syndrome commonly have associated hearing loss, as was mentioned earlier. So the type 2 collagen is often associated with a mild, high-frequency sensory neural hearing loss, and that affects about half the patients with that genetic. And collagen type 11 is associated more with a moderate hearing loss involving all frequencies. And this is more commonly associated with hearing loss. And then the collagen type 9 is a more progressive and pronounced hearing loss at the higher frequencies. And then you've got those non-collagen genes with sort of no or mild hearing loss. And also a lot of these associated with sort of orofacial manifestations have sort of middle ear sort of structural things going on with the middle ear. So focusing on this type 9 collagen, this was mentioned earlier as well, these are the different collagens here. So the red one is the type 9, and that's involved in the sort of tectoral membrane structure in the inner ear. So that's what gives this rise to the sort of hearing, sort of sensory neural hearing loss. And then you've got these sort of orofacial features, which could have some effect. So this collagen type 9 I was just mentioning was involved in the tectoral membrane in the inner ear, which gives rise to that sensory neural hearing loss. And then you've got these orofacial features that give rise to a conductive hearing loss affecting the middle ear. But this structure at the top here of the inner ear is the vestibular organ, and it's got these 3 semicircular canals, and that is where our balance function comes from. And so there's a lot of conditions, genetic conditions that affect hearing and balance, so which is why we're interested, because so far there's not any published data on how Stickler syndrome might affect balance function. So we're going to focus on this type 9 collagen, and we're recruiting patients with the help of Martin Sneed from the vitreoretinal service at Addenbrooke's. And this is sort of our plan. You don't have to read this, but we've just got ethical approval to do this project, and we've pre-registered the whole sort of plan for the research and data analysis to make it easier for us to publish quite smoothly, so that there is some data out there on balance function. So just going through what we're going to do then, so we want to look at this middle ear function, and we want to look at hearing, and we want to look at balance. So to look at middle ear function, we look at tympanometry, which is where we put a little bit of sort of air pressure in this ear canal. And then we play kind of a tone so that we can have a look at the function of the middle ear and the eardrum. And it gives us these kind of traces to show us what's normal and what's abnormal and how it might be abnormal. And then we look at audiometry, so like their hearing test, and that gives us also an idea of the middle ear function as well, and also of how the inner ear is functioning. And then we do this test of balance, which I'm going to explain in a moment, which is called video head impulse testing. It's much nicer than it sounds, but I'll go through that on another slide. So with the hearing test, we test only frequencies that are important to speech. So this is kind of like a standard kind of hearing test with a mild hearing loss on the right. So we do right red, and this is showing a bit of hearing loss on the left. And this is just to give you an idea of what hearing tests look like. And for children, we usually test a fewer frequencies than this because they just don't want to sit there and do all of these frequencies. But obviously, this is a very happy child having a tympanometry done, which only takes a couple of minutes, and they don't have to do anything for that. And that just looks at the eardrum, as I was explaining. So just to go through the balance function test then, this is a test of those vestibular organs. So the participant, this person here is sitting here with the goggles on. They sit in a chair whilst we make very small, quick head movements of their head, and we record their eye movements with a video headset. Because the speed of the eye movement is linked to the function of the balance system, and this is a reflex, the vestibular ocular reflex. So if I were to sit in a chair and look at a target and have my head moved quickly from one side to the other, if I can maintain focus on that target, my eyes are making an equal and opposite movement to my head to keep my eyes fixed on that target. And it's kind of like the ability to do that. It's a reflex. It's not something I'm choosing to do. It's a reflex, just keeping looking at the target. Gives us a normal value of 1 because it's a ratio of 1 to 1. Something less than that gives us an indication of an abnormality. So patients that might not be able to do this if there's a recent head or neck injury or some arthritis that's affecting the neck. But, mostly people can do this because it's a very small movement and just the ability to gaze at the target. We also ask patients to complete a questionnaire about their dizziness symptoms, and this gives an indication of sort of the quality of life. And there's a few different sort of questionnaires, but we've chosen one that's often used in research called the Dizziness Handicap Inventory. This is just an idea of the kind of data analysis that we're going to do, as we had to pre-register the research. So just to give you an idea, we're just looking at the sort of frequency of normal and abnormal hearing, and whether the hearing loss is conductive or sensory neural, or it can be a mixture of those two, and also kind of what their middle ear function is like, and whether that gain I was talking about, the eye movement to head movement sort of ratio, whether that's in the normal range or not, and whether there's anything else we can tell also from that testing. So the outcomes of the study, there's known links between lots of etiologies and hearing loss and balance. So we just want to know, is there a link here? And if not, we want everyone to know that there's not. And if there is, we want everyone to know there is. And the quality of life of people can be improved by treatment. Also this subtype of sticklers, there's not a lot of research on it because there's not a lot of people with it. It's hoped that the end result of this study will have a clear understanding of all of these functions we're looking at, and just inform treatment requirements for patients and medical professions in the future. Thank you very much. Yes.
So is dyspraxia what you're talking about, for example? Is there a higher rate of dyspraxia amongst?
So no. So the inner ear is how we know which orientation we're in, and that we've moved, and keeps us kind of walking in a straight line and that kind of thing. So the balance organs in your middle ear have kind of a fluid in them, and they're in 3 orientations. So you've got sort of a sideways one and 2 vertical ones. And when you move, that fluid moves, and it tells you that you're moving in a certain orientation. And if there's a problem with the signal from that to your eye, which is one of the fastest reflexes in your body, your eyes don't move the same as your head. So you kind of get either a spinning or a kind of weird disorientated feeling. So it's that kind of balance function.
So it's dizziness and
loss
of orientation.
Yeah, that kind of thing.
Thank you.
Hi there.
Does he want to go first, or is there any treatment for it? Because basically our son Tommy's 5 and he had a scan when he was probably a year old, and basically they said, is there 3 in each ear?
Yeah, so
balance organs.
Yeah.
So they then told us, I think it was it 2? Was it 2 in each ear? 2 in one and 1 in the other, which weren't formed correctly or formed. When you talk about something you can do, is there anything you can do for them, or?
Yeah, so we do. So 2 answers to that question. One is I've actually recently been to a conference where there was somebody with a malformed balance organ, and if you have it from birth, you often just compensate. And we look at kind of these VHIT traces of people who have compensated from birth, and they have what we call saccades, where the eye is, instead of being a reflex, the eye is learnt centrally with the central systems in sort of the middle of your brain to compensate for the fact that you're not doing that automatically. So they have a saccade that instead of your eye and your head moving equal and oppositely, your head kind of moves, and then your eye catches up very quickly and decides to move whilst you're still moving your head. So you don't get that.
Yeah, that's what we're amazed with, because like he's riding the bike, like even on the fun fairs, like nothing seems to.
Yeah.
And so I'm always worried that he's going to come off feeling sick, or he's. Yeah. But he just doesn't seem to bother him at all. Yeah.
And having something from birth, it's amazing. And if we did these tests on him, we'd probably know that he's compensated, but he's compensated. So it's not like if I were to suddenly lose my balance function now, I'd have a period where I'd need to learn. And that's the second answer to your question. We do like rehab where we can help people learn to compensate, basically. Yeah.
Yeah. I was just going to ask a question about the fluid in the middle ear, and does that change as you get older? And because I have more balance issues as I've got older than I ever did when I was younger.
Yeah, so there's two types of fluid. So the middle ear part between the eardrum and your inner ear, that kind of fluid can affect your hearing. But the balance organs, those semicircular canals, the fluid in those that helps you balance, is that what you mean? That there's, as you get older, actually all of our balance tends to kind of get a little bit worse.
Yeah.
But there's things, I mean, in simplest terms, keep moving your head. You have to use it or lose it in a way. So the more you move your head, the better.
Yeah. When I say balance, I meant like dizziness.
Dizziness.
Yeah. So like, yeah.
Dizziness is a complicated thing because there's loads of different reasons you could be dizzy. It could be a postural thing. It might not be your balance organs. The sensations in your sort of legs, the proprioception, that feeds into your balance system. Your eyesight obviously feeds into your balance system. Yeah. So all of those kind of things can compensate to you feeling sort of dizziness or imbalanced.
Yeah. Okay.
Any more questions? Thank you very much. That was great. Thank you.